In this video, we are going to discuss about Unit 5, Upper Layer Issues of WSN. Upper Layer Responsibilities for making sense of the data and providing useful services. In this upper layer, we are going to do in the sensors. Right? By using sensors, we have to gain some data, right, from environmental. Sense is nothing but sensors whatever the data is converting and transferring into the data, that all data is storing in the destination. As we already discussed in the previous video, we discussed what the sensor will do and what is the data and where the data is going to store. So, and data is providing useful services. In upper layer, in computer networks, we have OSI, right? In OSI, we have several layers are present. In that, what are the topmost layers are there? That is nothing but the upper layers. In the topmost layers are application layers and transport layer, right? So what is in the upper layer we have transport layers and application layers. So what in the presence of transport layer, what are the in the transport layer we have reliable versus efficiency and congestion control, pump slow and drain quickly. This is nothing but the agriculture industry level, which is using for the sensors by providing upper layers. Pump slowly, we are going to slowly we are doing pump, and drain, it can absorb the water quickly. This is the example of transport layer in upper layer issues of WSN. And congestion sensitive transport protocol, this is also called as CSTP. Okay, next, coming to application layer, data aggregation, data fusion, localization, right? These all are nothing but the application layers which are present in the upper layer. In upper layer means in TCP we have several layers, right? Physical layer, network layer, data link layer, and what are the topmost layers and are there? Those are nothing but the upper layers. Okay, next, what are the challenges in the upper layers? Upper layer of WSN: energy efficient, scalability, robustness, security. As I told in previous video, in ad-hoc network the security is limited, right? So, and because there is no infrastructure, pre-infrastructure, right? There is no physical connection between the devices in a network, right? So that is the reason why security is limited. That is a big challenge. Okay, and energy is efficient. Energy in fourth unit we discuss about the sensors. In sensors we have energies in the form of batteries, and some of them are taking energy from the environment, like sensor panels are there, then they are taking the energy from sunrise, right? Next, scalability and robustness is nothing but a strong. Next topic is transport layer. Okay, transport layer, it plays a crucial role in ensuring reliable and efficient communication despite the unique challenges these networks face. Okay, there are some unique challenges are facing in transport layer. What are the challenges? Dynamic topology is nothing but it is going to moving freely. Okay, not at constant level. Okay, that is nothing but the topology. And dynamic topology, constantly changing. Okay, it is free, right? It is free means it can move freely. It constantly changing from one place to another place. Connections as nodes. Next, wireless medium, signal interference, signal strength, resource constraints, limited processing power, memory, battery life. Resources is nothing but the battery life. Okay, what are the resources of transport layer? As I already told that the security and this energy efficiency and challenges of upper layer become limitless, right? In limited form only we are doing the upper layer transport layer in the resource constraints and security concerns, more vulnerabilities, right? Security is limited, as I already told in previous videos, and now also just before I told that security is limitless. Okay, why? Because there are some denial of services, and there are so many threats are we are occurring in the transport layer while transferring the data. For example, we are sending hi, then the receiver may receive hello because of there are lack of security in the AD-HOC networks, because there is no fixed infrastructure, right? So there is no infrastructure means there might be some threats. Okay, next, key functions. What are the functions are present in the transport layer? End-to-end reliability. End-to-end is nothing but the source to destination. Data is transferring from source to destination, right? So data from source to destination is nothing but the end-to-end reliability. That is nothing but the source node and destination nodes are communicating each other. Next, congestion control. Congestion control is nothing but managing congestion in network to prevent data loss. To prevent data loss in transport layer, we have data loss, right? There might be a pocket of data is going to loss in the in the AD-HOC networks, right? So we discussed already what is the loss of data, what is the loss of data in the form of packet. This all we discussed in the previous videos. Please check the previous videos and come to this channel. Okay, come to this video. Okay, next, these are the key functions of a transport layer. Next, flow control. This is also one of the challenges or key functions of flow control, right? Next, regulating the rate of data flow between sender and receiver. Flow control is controlling the flow from sender to receiver, right? This is nothing but a sender to receiver message is going to pass in, right? It can improve the performance. Why? Because if sender have high speed network and sender may send the data speedily, but the receiver has low network and receiver may be slowly he will open or he will receive the message. So in order to get this there might be some difficult, right, flow control. So there is a disadvantage in the flow control. So after doing the flow control, this is a function of transport layer, right? So it can regulate the rate of data flow. So it can regulate these both and it can transfer into the one single time, and it can improve the performance, so that it can improve the performance of the data transfer in the transport layer, right? Next, multiplexing and demultiplexing. What is multiplexing and demultiplexing? Allowing multiple applications to share the same transport layer connection and then direct data to the appropriate application at receiver. So at receiver also and at the sender also, we are going to share the same transport layer connection to the we are going to share the same data to the same transport, like multicasting. For example, this is a one node, these two are the one nodes, so these two are going to share the same, and we have some collision is there. So this all we discussed in previous videos. So this is also nothing but the directing the appropriate application at the receiver side. This is a receiver side, right? We are going to share the different data from source, different nodes, right? Next, design. Adaptability, energy efficiency, lightweight, security. Adaptability, energy efficiency, lightweight and security, these all are the design construction of transport layer. Next topic is high level application layer support. High level application layer support is nothing but this layer is responsible for providing services and functionalities to the user. This layer can provide the application layer. Okay, what is upper layer? In upper layer we have application layer, and as well as one more layer is transport layer. We discussed about transport layer just before, and we are going to discuss about the application layer. This is a high level, right? So in this layer is responsible for providing services and functionality to the user. This is the application, right? So in the application, the user interface and user can interact with the user interface. This is the application layer, and it can provide the services and functionalities to the users, which whatever the needs or requirements for the user. Next, data aggregation and fusion. Application layer can aggregate the redundant data to reduce the amount of information. In order to get data aggregation in the fusion, the aggregation redundant data is reduce the amount of information. It can reduce the amount of information that needs to be transmitted. So there are so many, for example, this is a receiver and there are so many nodes are present, and every node sending the same data in redundantly. For example, this node, what the data is coming from this node and this node are both are same, then the receiver in the application layer it can be removed or detected or reduced the amount of information, right? That is what the data aggregation. Next, these all are the functionalities, right? Next, location. Location is nothing but determining location of nodes is crucial in many applications. Location is must and should, we are using crucial in many applications. Next, time synchronization. Many applications require nodes to have a common sense of time. In the same common sense of time, we are so many applications requirements are coming from the nodes. To ensure this application layer can implement time synchronization. Time synchronization is important in the application layer in order to get so many redundant data from different sources. Okay, next, security services. Application layer can provide security services such as authentication. Authentication is one of the prevention of the security service in the presence of threats. Whenever threats are going like denial of service or anything, the authentication is important. Authentication and authorization. Authentication is nothing but check whether username and password are correct or not, whether we have to allow him, whether we have to allow him to the website or not. These all will come under the security services which are present in the application layer. User can directly enters into the application layer, right? So it is a user friendly. Next, challenges of high level application layer. Resource constraints, dynamic topology. Resource constraints, resources, whatever the resources are there, that all will constraints in the presence of application layers. And dynamic topology, as I already told that what is dynamic topology. Topology is nothing but the not fixed, right? Next, one more challenge is scalability. Scalability is also one more challenge. And here is the diagram for application layer. See, application, user can interact through the application, right? So user can interact to the application layer is interact to the internet is interacting with the data center is collection of data, okay, databases, okay, collection of data, and this is a gateway, okay, this is nothing but the gateway, and through this gateway the network infrastructures have sensor nodes. For example, this is the destination and this is the source. This is nothing but the end-to-end device, and this all overall is nothing but the network infrastructure, and this is information infrastructure. So whatever the information using for user, that is nothing but the information infrastructure, and whatever the data we need, that all is present in the network, right? So it is nothing but the network infrastructure. In between we have internet and gateway. Through this internet user can interact, and through the gateway the network infrastructure and internet going to take the what we can say, take the data, whichever data user want, okay, according to the user requirement. The data is going to extracting from the network infrastructure through the data center collection of data collection, nothing but database, okay. This is nothing but the application layer. This is how the user can interact to the network infrastructure. This is the diagram, okay. Next, adapting the inherent dynamic nature of WSN, okay. See, adapting to the internet dynamic nature of WSN. The dynamic nature of wireless sensor network is one of their defining characteristics and significant challenge. It is a one of the challenge, and there are some defining characteristics are there. What are those? We will see. WSN dynamics stems from several factors: node mobility, environment change, node failure, link quality function, network traffic variations. So what is node mobility? What is the node mobility? Sensors nodes might move, okay. Mobility is nothing but the sensor nodes may move. Okay, it may move. This is nothing but the node mobility. The nodes are going to moving from one place to another. Okay, that is nothing but the sensors nodes moving from one place to another. It can be might. Okay, that is nothing but the node mobility. Next, environment changes. What is environment changes? Sensor can change rapidly. Environment, based on the environment, the data is the nodes or the data which are present from the sensors that can be changed. Okay, that is nothing but the environment change. Next, node failure. There are some failures also present in the sensors, right? So sensors can fail due to battery depletion. So due to battery depletion, there are some sensors we do lack of batteries or lack of charging. We have so many nodes are going to fail because of the battery. Next, link quality fluctuations. WSN links can vary in quality due to interface. So it is based on the quality, right? So quality is also important, right? So links can vary in quality due to interference. Because of interference, the quality is going to vary from one place to another place or one node to another node in the network. And next one is network traffic variation. The amount of data being transmitted can change over time. It is nothing but a time taken process. Like time based on the time series, the network traffic variations are, it can vary from one place to another place. This is nothing but the network traffic variations. Next we have WSN employ adaptation mechanisms. It varies layers. So there are some layers. These are all layers in the computer networks, and we discussed in the previous video also. OSI. In OSI also we have same, right? Physical layer application, physical layer, MAC layer. What is physical layer we discussed? What is MAC layer we discussed? What is network layer we discussed? What is transport layer we discussed? What is application layer we discussed just before, right? These all are nothing but lower, and these two are the higher. Okay, this is nothing but the adaptation to the inherited dynamic nature of WSN. Next, sensor network and mobile robots. So it is nothing but the combining of sensors and as well as mobile robots. Okay, the mobile robots are nothing but it can directed by the some user. Okay, some operator. So one operator can maintain the mobile robot. The sensor network and mobile robot, it is nothing but a combining of sensor network with mobile robots. So we'll discuss what is the sensor network and mobile robot. Combining sensor network with mobile robots in AD-HOC environment opens up existing possibilities but also prevents unique challenges. It can also prevent the unique challenges which are present in the sensor and as well as mobile robots. And what is the sensor network and mobile robot? Through the sensor network, we are one operator can operate the mobile robot in the presence of sensor network. That these both are combining, and we are doing some extra, right? So it is a combination of sensor network with the mobile robot. Next, the energy of sensor networks and mobile robots. What are the energies we have in the sensor and we have in mobile robots, and if we will both combine, then what are the energy results we have, we will see. Next, enhancer sensing. Enhancer sensing means it can sense the different types of areas that can different or dangerous which human cannot access. Okay, there are some critical places, right? So that is nothing but dangerous places. In that cases also, the robot can by using the operator, by using the sensor network, the mobile robots can extract the details where dangerous places for human. There are some places which are not accessible for human to go. In that case also, the sensor network and mobile robots will go, and it can enhance, like it can research, right? So that is nothing but the enhanced sensing. So mobile robots Mobile robots can carry sensor nodes to areas that are difficult or dangerous for human to access. They are dangerous places human cannot access cannot access those areas. That also we are done with the mobile robots using sensors. Next, dynamic deployment. Robots can be used to deploy sensors nodes in a targeted manner. In a targeted manner, the dynamic deployment of robots can be used in sensor nodes. So the robot can be used to deploy sensor nodes in target manner, which are present in the dynamic deployment. Okay. Next, data collection and relay. What is the data collection and relay? Through the mobile robots along with the sensor, we have some data, right? In everywhere the data collection is nothing but storage. Okay, whatever the sensor give the data, that all data is combining and storing in the particular way. That is nothing but the data collection and relay. Robots equipped with the sensors can actively explore and monitor whatever the sensor can monitor, and whatever the data explored, those all data is combining, and that is nothing but the data collection. Okay. Next, search and risk. Okay, that mobile robot, right, not a human, right? So whatever the situations which human cannot do, that also we will do with the mobile robot. That is a big advantage in the sensor network with the mobile robot. Okay. In disaster scenarios, robots can be deployed to search for survivors. So there are some disaster scenarios are there. In that cases, human may be or may not be existing to enter in that areas. In that areas also, the robot, if will go, that because that is a robot, right, not a human. So that robot can search, and that robot can risk it. Okay. What are the challenges are present in the sensor network and mobile robotics? So we will discuss in each and everything. Okay. Challenges: data fusion and processing. Data fusion and processing is one of the challenge. Why? Because data fusion, right, how the processing is going, what are the issues are presenting, this all will come under the challenging. Next, security. As I already told, AD-HOC network is a lack of security. It can threats like denial of service, and there are so many different types of threats, right? Next, coordination and communication. There is a coordination and communication problems are facing in between sensors networks and mobile robotics. These all are the challenges of sensor networks. Next, example: precision agriculture. Precision agriculture. In the agriculture field also, we are using this type of sensors along with the mobile robotics. This is also to sense some environmental changes and to find the whether a crop is needed water or not, by seeing the soil moisture, or if the moisture is too much the soil is too much moisture, then it can prevent the, or it can stop, it can tell, and it can sense the way, and it can tell, or it can give the data to the user. That is nothing but the this is looking like IoT, Internet of Things. Okay. Internet of Things also have sensors, right? So through that sensors, we have operatings, different types of operatings, and it can directly converted the data into to the user or consumer, so that it can easy in the agriculture for water. Okay, for water. Okay. Next, environment monitoring. From 4th unit also, we are telling that we are telling so many things that environment is monitoring by the sensors, and it can give to the base station, and it can into the internet, and it can interact with the user, right? Next, industrial automation. Industrial automation is also one of the application and example for the sensor networks and mobile robotics. So in this video, this is one of the example diagrammatic representation of sensors, networks, and mobile robotics. How this whole process is going through the by combining sensors and network mobile robotics. This we will see here is one operator. For example, here is an operator there. He is going to operating something from remote. Okay, he is going to operating mobile robot through the remote. Whatever he will give the directions, the mobile robot will go and they will do their work according to his operator's actions. Okay, through the sensor node. This is how the sensor network and mobile robot is working. Through the operator's actions, whatever he will press on the remote, that signals will go, that radio signals will go to the sensor, and the radio signal will give the instruction to the mobile robot, so that the mobile robot can perform easily and quickly, so that the work whichever done by the operator or human being, this all will done by the mobile robot by using sensor node. This is nothing but the sensor network and mobile robot. That's all guys. This is all about 5th unit. Thank you.